In this video, we're going to continue our discussion of Taylor and Maclaurin series. The question here is to use series to evaluate the limit x approaches 0, 1 minus cosine x divided by 1 plus x minus e to the power of x. Now, this limit has the 0 over 0 pattern. Why is that? If you plug in x equals 0, we get 1 minus cosine of 0 divided by 1 plus 0 minus e to the 0. We get 1 minus cos of 0 is 1, and in the denominator we get 1 minus e to the 0 is 1, we get 0 over 0. When you have 0 over 0 pattern, that's known as an indeterminate form, so we can definitely use L'Hopital's rule to evaluate this limit. Alternatively, because the limit involves values of x near x equals 0, we can substitute the Maclaurin series of cosine x and e to the x and evaluate the limit. So let's start with the Maclaurin series of cosine x. Cosine x is equal to 1 minus x squared divided by 2 factorial plus x to the power of 4 divided by 4 factorial minus x to the power of 6 divided by 6 factorial plus x to the power of 8 divided by 8 factorial, and so on. And the Maclaurin series of e to the power of x is equal to 1 plus x squared divided by 2 factorial plus x to the power of 3 divided by 3 factorial plus x to the power of 4 divided by 4 factorial, and so on. All right, now let's look at the limit. We have limit x approaches 0, 1 minus cosine x divided by 1 plus x minus e to the power of x. Now our strategy is to substitute Maclaurin series of cosine x and e to the power of x into this fraction and then evaluate the limit by doing loss of algebra. So we get limit x approaches 0, 1 minus, and the Maclaurin series of cosine x, the first 5 terms of the Maclaurin series of cosine x is 1 minus x squared divided by 2 factorial plus x to the power of 4 divided by 4 factorial minus x to the power of 6 divided by 6 factorial plus x to the power of 8 divided by 8 factorial, and so on. And in the denominator, we have 1 plus x minus, and we substitute the Maclaurin series of e to the x, which is 1 plus x squared divided by 2 factorial plus x to the power of 3 divided by 3 factorial plus x to the power of 4 divided by 4 factorial, and so on. Now let's simplify. We get limit x approaches 0. Distributing the minus sign, we get 1 minus 1 plus x squared divided by 2 factorial minus x to the 4 divided by 4 factorial plus x to the 6 divided by 6 factorial minus x to the 8 divided by 8 factorial. In the denominator, we get 1 plus x, and similarly distribute the minus sign. So we get minus 1 minus x squared divided by 2 factorial minus x cubed divided by 3 factorial minus x to the 4 divided by 4 factorial, and so on. Now let's do some cancellation. We get 1 minus 1, that cancels out. In the denominator, 1 minus 1 cancels out, and x minus x cancels out. So we get limit x approaches 0. In the numerator, we have simplified it to x squared divided by 2 factorial minus x to the power of 4 divided by 4 factorial plus x to the power of 6 divided by 6 factorial minus x to the power of 8 divided by 8 factorial, and so on. In the denominator, we get minus x squared divided by 2 factorial minus x cubed divided by 3 factorial minus x to the 4 divided by 4 factorial, and so on. So we have simplified the limit to limit x approaches 0, x squared divided by 2 factorial minus x to the power of 4 divided by 4 factorial plus x to the power of 6 divided by 6 factorial minus x to the power of 8 divided by 8 factorial, and so on. And in the denominator, we have simplified it to minus x squared divided by 2 factorial minus x cubed divided by 3 factorial minus x to the 4th divided by 4 factorial, and so on. Now, let's factor out x squared from the numerator and denominator. Factor out x squared. So we get limit x approaches 0. Factoring out x squared from the numerator, we get x squared times 1 over 2 factorial minus x squared. Make sure you do the factorization properly, because when you multiply it, you should be able to get this back. You should be able to get x to the 4th back. And then plus x to the power of 4 divided by 6 factorial. And always check, ask yourself, x squared times x to the 4th gives you x to the 6 back, minus x to the 6 divided by 8 factorial plus, and so on. In the denominator, factor out x squared. We get x squared times negative 1 over 2 factorial minus x divided by 3 factorial, because x times x squared gives us x cubed back, minus x squared divided by 4 factorial, and so on. Now you can see that the x squares are going to cancel out. And that was in fact the factor that was causing the indeterminate form. It was causing the 0 over 0 pattern. So now we can just plug in x equals 0 and evaluate the limit. So we get limit x approaches 0, 1 over 2 factorial minus x squared divided by 4 factorial plus x to the power of 6 divided by 6 factorial minus x to the power of, this should be x to the power of 4. X to the power of 4 divided by 6 factorial minus x to the power of 6 divided by 8 factorial, and so on. In the denominator, we have negative 1 divided by 2 factorial minus x divided by 3 factorial minus x squared divided by 4 factorial, and so on. So we have limit x approaches 0, 1 minus cosine x divided by 1 plus x minus e to the power of x. We simplify this to limit x approaches 0, 1 over 2 factorial minus x squared divided by 4 factorial plus x to the power of 6 divided by 6 factorial minus, this should be x to the power of 4. I made the same mistake before. X to the 4 divided by 6 factorial minus x to the power of 6 divided by 8 factorial, and so on. And in the denominator, we have negative 1 over 2 factorial minus x divided by 3 factorial minus x to the 4 divided by 4 factorial. Now let me just double check this. It should be x squared divided by 4 factorial. So let me fix this here. It should be x squared divided by 4 factorial. Now, we're taking a limit as x approaches 0. So we're simply going to plug in, x equals 0. So doing that, we get 1 over 2 factorial, and plug in x equals 0. Wherever you see an x, plug in x equals 0. So you get minus 0 squared divided by 4 factorial, that's just 0, plus 0 to the 4th divided by 6 factorial, this one, which is just 0, minus 0, divided by negative 1 divided by 2 factorial, minus 0 divided by 3 factorial, which is just 0, minus 0 squared divided by 4 factorial, which is just 0, and all the terms that come after it are also going to be 0. So simplifying this, we get 1 over 2, because 2 factorial means 2 times 1, which is the same as 2. And when we divide, we reciprocate, so multiply by minus 2 factorial, which is 2, minus 2 divided by 1. Simplify this, 2 cancels with 2, and we get negative 1. This is the value for this limit. All right, let's review a bit. Now, it may not be clear how many terms of the Maclaurin series to use. The Maclaurin series that we use here was cosine x and e to the x. So in general, if you're not sure, use the first 4 to 6 terms of the Taylor series. In this example, we use the first 5 terms of the Taylor series for e to the power of x, and also the first 5 terms of the Taylor series for cosine x. And so basically, to summarize, we were given this limit. X approaches 0, 1 minus cosine x, divided by 1 plus x minus e to the power of x. And when we plugged in x equals 0 to determine the pattern, we found out that we had the 0 over 0 pattern, which is an indeterminate form. So we can certainly use L'Hopital's rule to evaluate the limit, but we wanted to get some practice using Maclaurin and Taylor series. So we basically plugged in the Maclaurin series of e to the power of x and Maclaurin series of cosine x. We did some algebra, we factored and simplified, and we evaluated the limit. All right, thanks.